Nuestro amigo HDMI aquí con mil errores, para variar. Nada, sobre todo vamos a seguir hablando de infraestructura como código, que ya creo que hoy va a ser un main topic y creo que lo tiene que seguir siendo para siempre, por favor, eso del ClickOps, obviarlo. En esta charla vamos a hablar de escalabilidad, gobernanza, security, IAM, todo con infraestructura como código. La presenta Jakub, Senior AWS DevOps Engineer, y tiene un montón de experiencia construyendo sobre todo landing zones como infraestructura como código. Por tanto, nada, Jakub, todo tuyo. Vale, gracias.
Ahora? Muy bien. All right. Well, first of all, we'll speak in English. I don't feel so confident with my Spanish. Alrighty. So first of all, thank you for coming for my presentation, The Code Behind Control. And as it was mentioned, we'll be speaking about how we can scale AWS governance, security, and IAM using infrastructure as code. So before we start, I would like to introduce myself. My name is Jakub. I'm from Slovakia, and I work as a senior software engineer at Virtuability. We're a small AWS consulting firm based in Ireland. And we help our customers with anything AWS related, but mainly we work with governance, security, identity access management, AI, MLOps, etc. But I'll talk a little bit more about virtuability later. Before we start, I do have a question. So Ruben did a very good introduction to IaC and all the benefits, but I'd like to ask you, how many of you already use IaC or infrastructure as code? Also, okay, most of the people. So before we start, let's remind ourselves, and again, Ruben did very good introduction, but let's remind ourselves why we use infrastructure as code. So first of all, with infrastructure as code, we can automate deployments of our infrastructure. We can easily and quickly deploy our environments. We can clone our environments, which is really helpful when we deploy short-lived environments, for example, for testing and development, but also in staging and production, which brings me to the next point, which is consistency across environments. We want to make sure that whatever we deploy to development is the same as what we have in staging, and want to make sure what's deployed in staging is also deployed in production. We get version control and easier rollbacks. So for example, if a new update to our infrastructure as code introduces a bug, we can easily roll back. And this also ties back to the automation. So we have automated rollbacks. We have testability, so we can test and analyze our code. But most importantly, deploying infrastructure is not really the differentiating value. So by deploying infrastructure, we're not really delivering value for our customers and for our business. The value comes from our application and whatever makes us distinct. So we want to spend ideally the least amount of time on solving infrastructure problems, etc. So again, deploying infrastructure does not necessarily mean delivering value. And so according to Firefly AI, the 2025 State of the IaC report, they surveyed hundreds of engineers and figure out that 89% of organizations have already adopted infrastructure as code. Yet only 6% have fully codified their infrastructure or their AWS infrastructure. And so from my experience working with different companies, I've noticed that the application infrastructure is not the main problem. Where we really lack when it comes to codifying our infrastructure is security and IAM. And so there is no real reason why we should use IaC for application as code, for application infrastructure, but not for our security and guardrails. So how can we do better? And so this is what I want to talk about in this presentation. I want to share with you 3 ideas, and these ideas are, we'll talk about how we can define our organization-wide guardrails, because these guardrails are the foundation for our security, and we want to make sure they're consistent. Then we'll talk about how we can build a robust, scalable access model for our engineers. And it needs to be scalable because as our organization grows, the access model needs to keep up. And the last one will tie to the first 2 topics. So once we have secure organization-wide guardrails in place, and we also have robust access model for engineers, we also want to make sure that engineers cannot elevate their access. So we'll be putting some guardrails around creation of IAM resources. And all of that will be supported by some architecture diagrams and code examples. The code examples will be in AWS CDK, but the concepts apply just as well if you use CloudFormation, Terraform, or any other infrastructure as code tool. So let's get to the first one. So before we even start talking about specific guardrails for IAM roles, we need to make sure we have we need to build a foundation. And in AWS, this foundation comes from security controls and resource control policies. So, let me take a look. Right, so with SCPs and RCPs, what we can do, we can create those organizational-wide guardrails, and we can deny things like disabling of organizational CloudTrail. We can deny deployments to unapproved regions. So for example, our organization won't only operate in Spanish region or in European regions. We want to make sure engineers cannot go and deploy something to Asia. Or we can also, with RCPs, we can deny changes or we can deny access to our data from outside of the organization. And as our AWS footprint grows to dozens or hundreds of accounts, keeping those guardrails consistent becomes really challenging, especially when we maintain and deploy them manually. So by defining them as code, we can leverage all the benefits of infrastructure of IaC, what basically Ruben discussed in his first talk, and what we discussed in the beginning of this presentation. And so this is how we can do it in practice. First of all, we start by obviously defining all of our policies in code. We can use something like CDK, we can use Terraform, we can use CloudFormation. And so with every commit or with every pull request, we can review those changes, we can review those policies, and we have an automatic pipeline that deploys it to AWS organization or to individual OUs. And so this is very simple, yet very effective model, but it has a couple of drawbacks or a couple of things that I want to mention. So first of all, with service control policies and resource control policies, there is a very small limit. So you can only attach 5 SCPs and 5 RCPs at each node in your organizational hierarchy. And by a node, I mean either OU or an account. So we only have 5 SCPs at each level. And so what we can do to scale this. So with each level, as you can see, we have AWS, we have the root OU, we have security, workloads, infrastructure, and then we have some nested OUs. With each OU, we can attach +5 as SCPs, +5 RCPs. And so this way we can scale them. Another thing that we can use to scale those SCPs is we can define multiple policy statements or multiple guardrails inside of single SCP, inside of single policy. So rather than defining one SCP for, let's say, disabling AWS regions where we don't want to operate, and defining another SCP for disabling or denying changes to our organizational CloudTrail, we just put them together. And so before we go to a code example, I have one more thing. If you are using AWS Control Tower, is there anyone who's using AWS Control Tower? Okay, a couple of you. So with AWS Control Tower, there is one drawback. And, well, Control Tower defines some SCPs for you. But it's worth mentioning that at the top OU, the top level OU, Control Tower will already deploy 2 SCPs. So we'll end up only with two slots for a custom SCP. So this is something you should consider before you start designing and building your SCPs. So I have a simple code example here. I don't really want to go through everything, but the most important part are here, the targets. So you can see that when you define SCPs in CDK, you can define either a root, your root OU, individual OUs, or individual accounts as targets. And so this ties back to ties back to the way we can scale the SCP. So we can define SCPs in a consistent manner with infrastructure as code. And for example, if we run out of slots at the root OU, we can define them, we can deploy them directly to the top level OUs. And then we can go down to maybe to nested OUs and to individual accounts. And we can make sure those SCPs are consistently defined. And so this is again how it looks on a high level. And with this, I would like to sum up the first topic and some lessons learned. So SCPs and RCPs are the foundation for our organization-wide guardrails. We can only have 5 SCPs and RCPs per node, and there is a character limit. We should definitely leverage organization hierarchy if we want to scale the number of our guardrails. And we should define our guardrails using infrastructure as code to leverage all the benefits that IaC brings with it, and specifically consistency, since we talk about security. And so once we have these organization-wide guardrails in place, we can jump on the second topic, which is identity and access for engineers. So to ensure right people have access to right resources under right conditions, we need to have a robust access model. And so specifically when it comes to access model for engineers, maintaining different or custom permission sets per each team gets really, and especially if we do it manually, it gets really complex to maintain and govern. And as our organization scale, it's also really hard to keep track. It's really hard to keep track of who has access to what. So, how could we improve it? An alternative to this is to standardize your access model. So, instead of having custom permission sets or custom access for each team, we can standardize it. It will significantly simplify management and governance. And we can do it, so we can start with creating 2 roles. We can have a standard role for day-to-day access, and we can have an elevated role. And this elevated role is used in cases when in staging or production or in those high-impact environments, engineers need to get manual write access. And so once we standardize this access model, this permission model, it's much easier to understand, to have a bigger picture of who has access where. Because you can see that in development environment, we probably want to grant our engineers more relaxed access, more permissive access. We want to make sure they can develop, that they can experiment, they can innovate. But once we move from development to staging and production, we probably want to tie down this access. We don't necessarily want to grant engineers access write access in staging and production. We don't want them to go and make manual changes. Because again, this ties back to inconsistency. What if someone goes and make changes in staging and they need to replicate it into production and they make a mistake? Now we are in an inconsistent state. So all changes to staging and production should go through deployment pipelines. Therefore, there is no reason for engineers to have access to have write access in production. But we can still have those elevated roles. And those elevated roles, if they really need this access, this write access, we can give it temporarily. So we can give them access for 1 hour, and then we revoke the access. And so how could we design those two roles, the standard and elevated roles? So we can base them on two policies, the view-only policy and read-write policy. The view-only policy doesn't really need any write permissions. It should have definitely read-only actions to the control plane, but not to data plane. Because in staging and production, you don't really need to have access to production data, not on day-to-day basis. The read-write policy, on the other side, can be more relaxed. We can even start with allowing everything, including data plane actions, except for sensitive actions. And then for those sensitive actions, for example, IAM, as we'll see in the third section, there we can introduce some conditions. So we can only create IAM role if certain conditions are met. And so this is how it could look in practice. Again, we start with a code repository where we define our standardized permission sets, our custom policies, the permission set assignments, and then we create a code pipeline or any deployment pipeline. And this code pipeline can go and deploy our policies through CloudFormation Stackset, for example, so each member account. Once deployed, we can create we can create permission sets through IAM Identity Center, which goes and provisions those specific IAM roles inside of our accounts. And to top it off, we can create AWS Control Tower. We can create event rule, which reacts on account lifecycle events. And this is really helpful because if we go and create a new account, we want this pipeline, this deployment pipeline, to trigger automatically and redeploy permission sets and permission set assignments, or at least update them if needed. And so this is another code example. And again, I don't want to go through everything, but you can see you can define both permission sets and permission set assignments using CDK. And we have a working code example at Virtuability's website. If you want to take a look, you can even deploy it to your account. It's really easy. You just define your permission sets in a YAML file with some assignments to accounts or to OUs, and it will go and deploy everything for you. All right, and so with this, we can conclude also the second part and some lessons learned. So standardized access for your engineers simplifies the management governance. We should have clear separation between low and high impact environments, so between development, staging, and production, to protect their sensitive data and infrastructure. When we define the access model as code, it dramatically reduces the risk of inconsistencies, and we also reduce the risk of security gaps. And we also benefit from other advantages of using infrastructure as code. So I keep coming back to those benefits because they're really important. And once you start thinking about, once you jump on this model of using infrastructure as coders, and you look back, it's like, why would we do it differently? Why would we not define it as infrastructure as code? And so once we have both organization-wide controls and secure access model in place, we can get to the third and the last part of the presentation. And so as I mentioned in the beginning, we have the guardrails, we have the foundation, we have access model, but we also want to make sure that engineers cannot go and elevate their privileges. So how can we do it? One easy way is to centralize creation of all IAM resources to your central team. So you have a security team, and then engineers are not allowed to create IAM roles, and every time they need to create an IAM role, they just open a ServiceNow request and they send it to the central team. That sounds great, right? It really fosters collaboration and it's fast and it's exciting. No, it's not, and it doesn't scale. Once your engineering teams start to grow and the number of requests starts to grow, this will create bottlenecks. And so what's better way? The better way, an alternative, is to empower your engineers and give them enough permissions to go and author their own IAM resources. In the end, it's the engineers who know what permissions they need for their applications. So instead of using or leaning to the gatekeeper approach, we can leverage guardrails. And so these guardrails can be based on permissions boundaries and paths. How many of you are familiar with IAM paths? Or so paths that you can assign to IAM roles? Not many, okay. So you can see up there, there is a little green circle, which is /workloads. And so paths are really just they're a string inside of your role's name, but you can use them to create guardrails. And I'll show you in a code example what we can do. Actually, the code example is right here. Great. So you can see here, we have some IAM actions, which are considered sensitive, because you can create an IAM role, and if you don't have any guardrails around this IAM role, someone could just go and create administrator access role, or a role with administrator access, pass it to EC2 instance, SSH into EC2 instance, and out of sudden they have full administrator access. So with this, with the path, we can say, okay, engineers can only create IAM roles or modify IAM roles if it's under this specific path, and only if they assign a permissions boundary to it. And then later, what we can do is we can say, okay, engineers can only pass role to AWS resources if it's under this specific path. And we know that it is, if any role under the path also has permissions boundary to it. And same with STS assume role. So this will create a safe boundary for our IAM roles and make sure any IAM role created by engineer does have a permissions boundary. And we can specify what permissions are allowed under permissions boundary. And so we should definitely top it off with service control policies. And this is called policy layering or defense in depth. So we want to make sure that we want to make sure that these guardrails are not in place only for specific IAM roles, but we also enforce them on the organizational level. Oops. And so you can see here what we do is we make sure that engineers cannot go and modify our permissions boundaries. And we also just duplicate the policy from the from the custom policy. And again, it's duplicate, but it's defense in depth. So even if someone managed to compromise their IAM role and grant themselves more permissions, they're still blocked by service control policy. And one more policy statement. So here we do the same thing for IAM pass role, but we saw it in the previous example. So if you are not familiar with pass role, it's a permission, it's an action that you need to have. If you want to pass your IAM role to AWS service and tell it, okay, go and use this IAM role to do whatever you need to do. So when you create EC2 instance, Lambda function, ECS, you also need to have pass role. So a couple of tips when it comes to creating permissions boundaries. You should create those permissions boundaries in a centralized repository. At least this is what I believe is the best way to do it. This is what we've done with our customers. If you have a central repository where you create either your policies, where you create your access model policies and the permissions boundaries, engineers can come in, they can issue pull requests, they can make changes, and then you have central security team who goes and reviews them. And so this fosters collaboration, it also makes the process faster and removes the bottleneck on the central team. You should create one general permissions boundary for typical workloads. And AWS has a really good example here. You can take a photo if you want. You can take a look. We use this as the starting point for permission boundaries that we created for our customers. And then once you create it, you will see, okay, we're missing this permission, so you can iteratively add more permissions as you go. But this is a really good starting point. But you will also see that there are some workloads that fall outside of the scope of the typical permissions boundary of the typical application, and they require many maybe control plane permissions that you don't really want to grant to the main permissions boundary. So for these, you should create one permissions boundary for each exception, and there are two main reasons. The first one, you don't really want to conflate or you don't want to mix different use cases, because in the end, that would be the purpose of using permissions boundary and limiting scope of permissions. And the second one, permissions boundaries are just simple policies. So they have a policy limit. If you start putting multiple use cases together, you might run out of the character limit. So it's better to keep them separate. And you might think, okay, but creating one permissions boundary for each exception, that's just a lot of manual work. But it's not, because you're creating them using infrastructure as code. So you define them once, and and that's it. And so when it comes to deployment, we have two options. We could just leverage the existing infrastructure we have for our access model. We could deploy our permissions boundary from the same repository as we do for our access model. And then CloudFormation Stacks will go and deploy it to every single account. Oops. Or we can just create similar infrastructure and deploy it again with CloudFormation Stacks. I like this approach because it simplifies it just simplifies your overall footprint. But well, the options are limitless. And so to conclude the third part, let's take a look at some lessons learned. So we should prefer to use guardrails to enable engineers to create IAM roles instead of leaning towards the gatekeepers approach, where we have one centralized team which will author the IAM resources for our teams. Permissions boundaries combined with paths will create a safe space for compliant roles. We should share the responsibility for creating permissions boundaries in a central team, because security should be it's a shared responsibility, so we should treat it so. And we should create one permissions boundary per use case. And so with this, we concluded the last topic, the third topic of the presentation. I would like to do one more conclusion. So let's take a look at everything. So we should definitely treat security guardrails and IAM just like we treat our application infrastructure. We should define it with IaC. We should use deployment pipelines to ensure consistency and scalability. We should standardize the access model for engineers to simplify governance and management. And I would also argue to increase security, because if you standardize your access and you know who has access to what and you know everything is consistent, then that might be more secure than you creating custom permissions for each team. You should put in place guardrails around sensitive IAM actions and allow engineers to create their own IAM resources, specifically IAM roles, and then define policies in a central repository. As mentioned before, security is a shared responsibility, treat it so. Let engineers to create their own permissions boundary or to make changes to permissions boundaries, and let them understand also, this will force them to understand the inner workings of your access model or of your organization guardrails. And so with this, I want to say thank you. I would love you to get in touch with me, either on LinkedIn. You can find me on my handle. I have a blog post where I occasionally post something about governance, security, or AWS in general. Or just come to me after the presentation. I'll be happy to talk about anything I discussed or anything else. And then I just wanted to say a word about Virtuability. So we're AWS Cloud Consulting Partner. These are some of the things we help our clients with. You can scan a code if you want to learn a little bit more. You can send us an email or just come to me and talk to me after presentation. I'll be happy to tell you what we do. And if anyone has any questions, I think now it's perfect time, and I'm happy to answer them.
Hola.
Sí.
Hola.
So first of all, thank you for the talk. Very interesting, and I think that very relevant in order to start to work in the cloud paradigm. And I have a question related to just-in-time access. Mm-hmm. You mentioned that in high environments, you should grant elevated permissions, elevator. And the question is, should be anything, someone or something in charge to approve this assignment, or how do you manage when some engineer request for assuming this kind of role?
So the answer is yes and no. It depends. It really depends. I think so for majority of accounts, production staging accounts, or it really, maybe you want to differentiate between teams. Maybe you want to differentiate between your production accounts, maybe between teams. If you, for example, have an on-call team who's on call and at 2 a.m. they receive a pager and saying, hey, look, there is something wrong in production. You don't want them to wait for someone to go log in and approve the model, to approve the access. I would say those things, so we say, okay, only deploy things using infrastructure as code and don't make manual changes. It sounds great. It's a nice idea, but you will find situations where you need to go and make changes. I think you can. So again, it depends on the security, on your security. The appetite, so risk appetite of your organization. You might just automatically approve them, and then you might have some specific production accounts where you say, okay, no, if someone really wants to go to production and they are not on call, they need to get approved access. And also depends how you do it. So, for example, if engineer needs to go and just quickly they need to log into their account to destroy some S3 bucket, right? And they need to wait for a week to get this elevated access. That doesn't work. So I would say, well, it depends. You can definitely just approve it automatically and ask engineers to provide some description. Or if you have some very sensitive workloads, you might want to put some manual approval behind it. So sorry, I didn't give you a specific answer, but I don't think there's a specific answer.
No, that's right. Thank you. I want to know your opinion about that based on your experience. So cool. Thank you.
Well, then with that, 1 second. Thank you.
Ok, perfecto.